Good morning. Okay, so this is the bit where you're rearranging an equation to make it say x equals, or in this case x squared equals, so that you can then create an iterative formula and keep stubbing your values back in, and then you get a convergent sequence, hopefully, towards an approximation for the root. Well, the sequence converges to the root, but anytime that we stop, we just get an approximation. So there's the way I did it in the grey and the way that you've done it. I actually prefer yours, to be honest. I don't know what I was particularly thinking. I love that you started at the bottom. That is the perfect trick. It's the easier way to do it. So you took the thing you were aiming for and put it down here, and then multiplied both sides by x, and then added x and took 3 off both sides and ended up with that, and then literally just wrote that the other way around. So it looks to the examiner, well, it would, especially if you hadn't put the arrows going up, giving away your secret method, which is okay, there's nothing wrong with your method, but it would look to someone reading it downwards that you, for no apparent reason, just wrote this the other way round and then rearranged it to say x cubed equals and then divided through by x. So yeah, perfect. I think what I was doing, you were asking what I did on the first line, I think I just subtracted x squared from both sides and and then subtracted x cubed from both sides as well. So I basically swapped the side that they were on, and then because I wanted it to say x cubed equals, I times both sides by -1. So then that changed to positive, that changed to positive, that changed to negative, that changed to positive, and then I divided through by x. But I can't tell you why I did it in that order. The way that you rearrange doesn't matter, so long as you don't cheat and you end up where you want to end up. So yeah, yours is perfect. Yours is better than mine. I like yours better. And I nearly forgot to say, I just went to press stop and then I was like, wait, there was another thing I was going to say, is that you asked me about this question and then you asked me about this question, which is nothing to do with, well, I guess it's the same topic in that we are going to approximate a root of an equation, but this one is about where two graphs cross and using change of sign argument, whereas this one is about setting up the iterative formula. So kind of two different topics, but both have the same foundation, which is understanding that whenever you have an equation, you actually can think of it graphically, all equations. So if I have an equation that's like something equals 0, then the question that I'm asking is, where does the graph of y equals blah 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 cross the graph of y equals, and then you look at the right hand side, 0. Y equals 0 is the x-axis. So let's say then we move some things from side to side. So we have now some stuff here equals some different stuff here. Now we have an equation that says, where does the graph of the left hand side cross the graph of the right hand side? Y equals blah 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 blah. And there is one in particular way of rearranging this that is going to be useful for us in the way that we use the iterative method. So the iterative method is based on us doing a particular type of rearranging, and we have to end up with x equals. Doesn't matter what's on the other side. Well, it kind of does matter what's on the other side in terms of whether or not it's going to converge when we do the iteration, but you don't need to know the details of that. Or the most important thing is, for the iterative method, we want x equals. And then that becomes our iterative formula, and this has x n's in it, and then we use that, put stuff back in. So the one that we've done in this question where we've rearranged it, we can't actually use that as an iterative formula yet because it still says x squared. So we could swap the x squared and the x, or like we could move everything apart from the x to the other side. So we could have x equals x squared plus 1 minus 3 over x. That would potentially be okay as an iterative formula. Xn plus 1 is xn squared plus 1 minus 3 over xn. that might work. Another thing that we could do is we could square root both sides of where it is now. So it says x equals x minus 1 plus 3 over x all square rooted. We could do that, and then that would say x equals. So we would have a different iterative formula. And it may be that one of those is going to create a convergent sequence and the other one isn't. But the important bit is, in order to do this method, in order to do the iterative method, we have to take our equation that we may want to equal 0, or it might just be this equals this, and we go rearrange, rearrange, rearrange until it says x equals, and then we use that. And you did the perfect trick of taking the thing you want at the bottom, work up the page. It's generally easier than working down the page. I hope that answered the question. I'm not 100% sure what it was you were confused on, because your algebra is perfect. So let me know if that doesn't answer the question properly.